Our next speaker will be talking about combining domain knowledge with data to track and predict heavy equipment service events. Please join me in welcoming to the stage Senior Data Scientist of Caterpillar, Davide Gerbaudo. Hi, Davide.
Hello, everyone. Good
Thanks
morning, Artie. Good
for
morning,
joining.
everyone. Thank you, Artie, for introducing me, and thank you to the conference organizer for inviting me. I am super excited to be here talking about our data-centric journey at the future data-centric AI. And my name is Davide Gerbaudo, and I work for Caterpillar, and I'm going to tell you about our journey with combining knowledge with data, and I'm going to share my screen. I hope you can see my screen. Okay. So today I will tell you about how at Caterpillar we combine knowledge with data, and we use that to track and to predict heavy equipment service event. So just a bit about my background. I'm not a computer scientist by training. I am a physicist by training. I spent about a decade working on these big particle physics collider experiments that you can see here. And that's where I learned how to use machine learning techniques, mostly sifting through data to look for rare collisions. And in particular, I spent a lot of time looking for the Higgs boson. And then generating these plots to understand if the Higgs boson exists or not. And then in 2012, the Higgs boson was discovered. And so in the past 5-6 years, I've been working with Caterpillar and doing data science at Caterpillar. So today I will tell you just a little bit about Caterpillar products. You might know the big yellow machines, but I need to tell you a little bit so that it will help understand what are the type of data that we work with. And then I will focus on what are the main problem that we're going to discuss today, which is classifying service events. Then I will tell you a bit about our journey, how we went in this classification problems from rules, models. And I will conclude by giving an outlook and providing you some idea about what's the value that this type of classification solution provides. So Caterpillar is a big enterprise. It's almost 100-year-old. It will turn 100-year-old in 2025. And at Caterpillar, we make heavy equipment. There are about 4 million pieces of equipment around the world. And they go from anywhere from the small wheel excavator that might be digging a hole in your backyard to the large mining truck to engines, turbines, and locomotives. And these heavy equipment, these pieces of equipment, these 4 million pieces of equipment are sold and serviced by a worldwide network of dealers. There are more than 150 dealers who are selling and servicing these pieces of equipment around the world. So if you think about a piece of equipment, a Caterpillar piece of equipment, it's not your typical consumer vehicle. It's not like your car. The Caterpillar piece of equipment is built to last for decades. And what we say is that it's built to be rebuilt. And what I mean by that is that if you look at this mining truck, it's much more complex than your car. Your car, usually what you do is that you buy it, you do your usual maintenance, you change the oil, the filters, you run it for like 10 years, and then when it's worn out, you dispose of it. Caterpillar pieces of equipment are built to last for multiple decades. And the way in which this is achieved is that these pieces of equipment are built to be rebuilt. What I mean by that is that if you take this mining truck, it might work, let's say, 16 hours a day, 7 days a week. So every year it works for more than 1,000 hours. And so when you get to like 10,000 hours, you might need to rebuild the engine of this piece of equipment of this truck. And then when you get to 15,000 hours, you rebuild the transmission. And then 20,000 hours, you build the engine again. And then you rebuild the engine and the transmission, and so on and so forth for multiple decades. Here you have pretty much one cycle in 10 years, but you do that multiple times. And this is how our customers get value out of our products, because they invest quite a significant amount of money to purchase it, but then it will last for a long time. And so these are the service events that we're interested in. These type of engine rebuilds, transmission rebuilds, and so on and so forth. And in the division where I work in Caterpillar in aftermarket analytics, you can imagine how it is important and critical to detect and classify these service events. Remember, we have like 4 million machines running all around the world, being serviced by 150 different dealers. And so we really need to understand when these pieces of equipment are being serviced. And to that goal, we have developed a process where we identify service events from the past, and then we also use that to predict the upcoming ones. So you can understand how this is critical in the whole enterprise. Now, what is the type of data that we can use to identify and classify these service events? We have a vast amount of internal domain knowledge. Remember, it's a 100-year-old company. There is a lot of information that has been accumulated over these years. And in particular, for each one of those products that we make, we have access to the blueprint. That means that we know down to the nuts and bolts what are the parts that are on each machine, what are the parts that can be replaced, what are the parts that cannot be replaced. Then for each machine, even the ones that have been produced like 20 years ago, we have an operation and maintenance manual. Keep this in mind because it will come back later on, and this is like a critical piece of information in the whole classification process. So this is our internal knowledge that we have in the company, and then we have lots of transactional data, and this is really the events that we want to classify. For example, if a customer is rebuilding the engine of their truck, they will come and buy parts, and so we will have access to an invoice where we will see the parts that the customer has purchased to service this piece of equipment. Then if the dealer has performed the service, we will also have access to some kind of logbook. We call it the work order, but it's pretty much a logbook of what the dealer, the technician has done at the dealership. And here you will see a different type of pieces of information. You have some numerical data, some codes, some free text. And of course, if free text is coming in different languages because we have this all over the world, and so on and so forth. And then out of those 4 million pieces of equipment running around the world, we have more than 1.4 million pieces of equipment that are connected. What I mean by that is that there is electronics on the equipment that is sending us time series data. And that time series data is providing us information about the health of the machine. And so as you can see here, we have very heterogeneous data sources. We have in principle a simple problem. It's a classification problem, but we have heterogeneous data sources. So then one could think, well, it's a classification problem. It should be fairly simple. However, it's not just a classification problem like separating cats from dogs. This is something that anyone can do. You don't need any specific knowledge to differentiate between a cat and a dog. In our case, we have multiple components that are in these big pieces of equipment. We have engine, transmission, torque converter, differential, and so on and so forth. And for each one of them, one needs to know how this piece of equipment and how the component of this piece of equipment can be serviced. And here is where the collaboration with subject matter expert is critical, because while everyone can separate a cat from a dog, not everyone can tell you if it's an engine rebuild or an engine replacement. And so this is where we started this strong collaboration, data-centric collaboration with our subject matter expert that have the domain expertise to perform this type of classification. And so let's take the example of an engine. We go, and the good thing is that in Caterpillar, we have access to these subject matter experts because they are part of the company. And you can probably find the person who has designed a good portion of this type of engine. So you go and talk to them, and they will tell you, well, an engine is simple. You have a crankshaft rotating down here, then you have pistons compressing the air and the fuel, and then you have cylinder head with valves, and so on and so forth. And they will start telling you rules, basic rules, where they say, okay, you look for valves and pistons, and when you do that type of service event, you also replace some bearings here. And then they will give you rules such as if you have more than 75% of these valves, then you call it one way, you label it one way. If you have more than 50%, you label it another way. And if you have less than 30%, you label it another way. So you have these rules from the subject matter expert. And at this point, you could think, well, it's so simple, I could implement it in SQL. I don't need any machine learning, it's just rules. And the first thing that you do, that you realize when you look at the data more in detail, combining with the subject matter expertise, is that the language that is used by the subject matter expert might not be exactly aligned with the information that's in the data. So here, for example, we look at a customer invoice. Yes, you can see the parts that the subject matter experts told you that should be there for this type of service event. But to do that, you need to actually interpret that with the engineering data and then combine it with some information from the logbook. So what you really need to do at the beginning is to build features that make it possible to interpret and to summarize the underlying data, and so that you can transform this underlying data and interpret it in a comprehensible way. But at this point, one could still argue that it's a relatively simple classification problem. And here is where the connection with the business makes the problem a bit more difficult and interesting, to my opinion. And to try to convince you of this, I'll use this lasagna analogy. I don't use it just because I'm Italian and just because it's getting lunchtime, so it's a good way to grab your attention. But I think it's a good analogy to illustrate the intricacies and the complications that arise when you want to develop a classification solution that is aligned with the business needs. So let's say that instead of classifying service events, we want to understand what are the dishes that are being served out there in the restaurants. And so let's say that we want to find when lasagna is being served out there. So we want to classify dishes as lasagna. And so the first thing that one could do is, okay, we know the recipe of the lasagna. We go look it up. It's actually in a book from the 14th century. And remember the operation and maintenance manual that I mentioned at the beginning. Well, this is a bit, the recipe, the original recipe of the lasagna is a bit like the manual of our machines. Somebody has taken the time to write down the exact rules of how you should cook this lasagna or how you should service our machines. However, when you go out on the field, you see that nobody is pretty much cooking lasagna following that exact recipe. Nobody is servicing our machine by the book. And so you will never see the service event done by the book. So at that point, you say, okay, the theoretical recipe is not working. Let's go and talk to the subject matter experts. And here you talk to the first subject matter expert, and he or she will give you a recipe for lasagna that is very simple with only basic ingredients. And then you talk to another subject matter expert who prefers to add also carrots and eggs in the lasagna recipe. And then another one who's very specific and will tell you even the brand of the tomato sauce that you should use. And so now you can see the second complication. You start with a theoretical recipe, and then you have the subject matter expert variations. They don't always agree with each other. And then you go to what's happening on the field, and you see the day-to-day approximations, because on that specific day when this lasagna was prepared, they didn't have the specific ingredient that this subject matter suggested. And so what they did on the field was to use an approximation of the variation of the theoretical recipe. And so you see where it gets complex. And now it gets even a bit more complex, because when you want your model to be used by the enterprise, by the company, you want to align with the business need. And the business might need to classify this lasagna as lasagna bolognese or vegetarian lasagna or full meal. So you see that these labels that the business needs are not necessarily aligned with the subject matter suggestions, and they're not aligned with the theoretical recipe. And this is where all the difficulties come in this classification problem. So what did we do in our initial solution? We did exactly what I said. It was so simple that we had our data that was mostly tabular, but also some other attributes, but mostly in databases. So the data scientist implemented a SQL rule-based logic that was developed by talking to the subject matter experts. And then the subject matter expert would provide feedback. I will tell a bit more about this central part, this visualization, which is critical, in my opinion, in this process. And you build this SME in the loop cycle where you have the SQL rules that are built, your model that is developed, the subject matter expert provide you feedback, you loop that in and you improve your model. Now, these approaches easy to explain because everybody understands rules. You don't need any explainability for a rule-based logic. It's easy to scale because SQL is almost by definition out of core, so it's easy to scale to large volumes of data. However, as we will see, it has limitations, and these limitations are because the SQL is rigid as a language. It's difficult to do the bookkeeping and also to scale the labels that you can achieve with this approach. Now, as you can see here, the visualization is at the core of this cycle. And here I want to tell you a bit more why it's at the core of this cycle. You have to keep in mind that subject matter experts are people, in this case, are people who have very specific knowledge and they're very busy. And so what you want to do is you want to optimize your subject matter expert time. And so what we found to be very useful was the first thing is when you show your service event and you want to get feedback from the subject matter expert, you summarize it. You provide here only the critical details about this service event. And then once you have that, you ask a very simple question to the subject matter expert. Is this service event an Axel rebuild? Yes, no, period. That's the simple way to ask the question. It reduces the overhead on their thought process when they look at this service event. But then what you do is that you also provide all available details. And that's because it might be data that is heterogeneous. It's lots of data. You might have invoices with like hundreds and thousands of parts in it, but the subject matter expert knows which ones are the important details in this invoice, which you as a data scientist might not know. So subject matter expertise is really critical here. And you also want to provide a good way to filter and skim through this data because it's a big volume and you want them easy for them to be to skim through this data. And once you've done that, you start understanding how your subject matter expert thinks about this specific service event so that you can start engineering features. And by engineering these features, by building these features, you are pretty much trying to summarize and think to the service event in the same way as the subject matter expert thinks about it. And some of them at the beginning will not make sense, but in the long term, it's useful because along with the labeling functions, and what we'll do is that we will force you to look at these service events in the same way the subject matter experts looks at them. One lesson that we've learned is that, as I mentioned, you can start with SQL, but SQL is very rigid as a language. And so let's take the example of this engine rebuild where one subject matter expert tells you you need 12 cylinder heads to have this type of label. And then you look at some examples and you see this one has 9. Okay, so it has the part that you told me, but it has 9 of them and not 12. And then another subject matter expert will tell you, oh no, actually 8 is enough. So one thing that you want to keep in mind when you build your logic, you need to make it easy to evolve. And SQL might not be the right tool, so you might want to move to Python, for example, where you can build features that are a bit more advanced, and then you can feed these features to machine learning tools. And these will help you to deal with the fact that there will be conflicts between the SME's opinion, and these opinions will also evolve over time. The other lessons that we've learned in our data-centric journey is that when we start, usually the classification problem has a very simple labeling schema. We started, for example, with engine, just with 3 different labels. Either it's an engine replacement or an engine rebuild or an engine minor repair. However, you need to build your process so that your labeling schema can evolve over time. And the reason for that is because as your classification solution becomes more popular across the company, it gets adopted by the company, you will have to label these service events for different business units. And so different business partners will want to call that specific service event in different ways. For example, here you might have a marketing unit that wants to look at engine rebuild, but wants to look at it in a more granular way. So they want to understand if it's a complete or a partial or more granular type of classification. And then on the other extreme, you might have an engineering team that wants to look at a more generic classification of engine service events. And so one solution that here we found to work quite well is some kind of hierarchical classification where you have several models that are chained one after the other with different level of granularity and different labeling schemas. So coming towards the end, how does this classification solution generate values and is useful to the company? To me, there is some fundamental usefulness in this classification problem, which in theory it's a simple problem, but in practice has some very profound way of transforming how the company works. And the reason for that is because by building a classification solution that is built around domain knowledge, what you're really doing is that you're transforming anecdotes into strategic collaboration. What I mean by that is that while before you might have like an engineering team that talks about one specific service event and they say, oh yes, in that service event for that engine rebuild, we used the kit that this marketing team developed. Now by introducing a classification solution that is aligned with the business language and aligned with the domain expertise that you have within your enterprise, what you're doing is that you're classifying that service event with different labels that are aligned to the needs of each business unit. And then at this point, what the engineering team might be saying is, you know, for this type of service event, we are using 70% of the times the kit that was developed by the marketing team. And so you can really transform this anecdotal evidence that you had before into strategic collaboration across different departments of the company. And so concluding, I hope I have convinced you that this classification problem works really well when you can combine the existing domain knowledge of the company with the data that you have. The other lessons learned is start simple. Even SQL is good enough to get things going and to get the model understood by your business partners. And then only when you reach the point where your tool is not good enough anymore, you can move to better tools and better techniques. Programmatic labeling and feature engineering is key because it's the way in which you can gain engagement, because now you're looking at the service events in the same way the subject matter experts look at them. And so you're talking their language and it really helps you to gain engagement. And then defining your target classing, your labeling schema is the main business problem, because this is something that will evolve over time and it will make your classification problem more complex. So here I also want to acknowledge the awesome team that I have the pleasure of working with, who have been working on this classification solution. And I'm happy to take any questions that you might have. Thank you.
That was such a great presentation, Davide. I really liked the lasagna analogy, very unique, combining machine learning with food. And of course, I love the snorkeling photo as well. So thanks for that.
Thank you.
Yeah, so we have a question coming in from the audience. Alexi asks, how do you predict catastrophic events like engine failure? Is it more real-time prediction?
There are two types of catastrophic failures that we can predict. Some of them are based on things that wear out slowly. So there are some type of components in our pieces of equipment that wear out very slowly. And those you can monitor and you will see that they come up over time. Then you have the catastrophic failures that happen all of a sudden. And for those, you can only use the machines that are connected, those 1.4 million machines that are sending data. In that case, you have time series data that you can monitor, and then you can start seeing some symptoms in the time series data that could help you predict those catastrophic failures.
Got it. Just a follow-up question for those who may not be familiar with the space, like what sort of data does that look like? The one that's like sort of real time from the machines that are connected, you said?
It's usually lots of sensors that are on the machine. So it could be temperature sensor, pressure sensors, all these type of things. And usually they come up at some frequency of hertz. So it's not high frequency, it's like order of hertz, and then you can get that data. Some machines have higher frequency, but most of them, it's about hertz.
And then do you need to then deploy the machine learning model sort of like at the edge for like the real-time inference, or how do you think of that? Yeah,
that is still being developed. It depends on the computing resources that you have at the edge. Sometimes it's possible, sometimes it's not. Yeah.
Got it.
Electronics is also evolving very fast.
Really exciting. Smaller models, quicker. Yeah, no, exciting space.
Yes.
Okay, another question that we have is, how are you thinking about tracking status or health of a machine by classification of repair types across several invoices?
Sorry, I didn't get the question. Can you please repeat it?
Yes, it's also in the Q&A tab at the bottom if you want to see it. But it's Trung asks, how are you thinking about tracking status or health of a machine by, let's say, using invoice data?
Yes. This is actually something, it's a real business problem. What happens is that sometimes a machine might break and then it gets repaired, and then something gets done incorrectly and then it gets repaired again the week after, let's say. And so this is something that is a difficult problem in the sense that you can have many false positives. You can have, sometimes it's just an issue in the invoicing process. The invoice gets duplicated in some ways. Sometimes it's a real recurring problem, and so you can have that the same issue is appearing across multiple invoices. So this is where talking with the subject matter expert is also helping you a lot, because they know how things are being done on the field. They know exactly how that data gets into the invoice. And so, yeah, it's a very interesting problem, and we are working on it.
Thank you. Okay, switching gears a bit, Brian asks, are you using sort of anomaly detection techniques to work with the time series and sensor data?
Yes, there are anomaly detection techniques that Caterpillar uses. They're not the topic of today's presentation, but yes, there are.
Okay. And then Vinny asks, with the data-centric model you've designed at Caterpillar, were you able to generate a dashboard type engagement for an easier internal UX? So I guess more downstream.
Yes.
Yeah.
Yes, many dashboards, and it will depend a lot on the business cases. So you have to imagine that we classify these service events, and then we have many different business cases. We might have different business cases for marketing and KPIs, business cases more for the engineering side. And yes, absolutely, there are different dashboards with different UX that are based on this type of classification.